So in a for loop, or if the I++, ++I are on lines by themselves, it's really not going to matter which one we pick. You can relax and not worry about it. Usually. Now that's definitely true for C or Java, and it's generally true for C++. So for ++I, we're going to add 1 and then send back the value in the variable, just like you'd expect. Now what about I++? Do we just send back the value that's in there right away and then sort of make a note to ourselves, or the compiler makes a note to itself to go back and add 1 later? When would later be? Does that really make sense at all? No, that's not what happens. So here's what's actually going on when we do I++ or any other variable ++ of any type, not just ints. What we do is we first make a copy of whatever that thing is. We ++ the original variable, adding 1 or moving the pointer or whatever it happens to be overloaded to. Then we send back that copy, not the original. So you'll notice I can't really do things this way unless I'm making copies. And if I'm in a loop, I could have millions of these things, and so I could be making like millions of tiny little copies to do I++. And so it seems like that could waste a tremendous amount of memory. But actually modern compilers, for simple stuff like ints, for your basic case of a simple straightforward for loop, have optimized this all away, so it's really a non-issue. And that's going to be true for C or Java. But in C++, we can overload ++ to work on all sorts of different types that the compiler's not necessarily going to optimize, and that may actually use a lot more memory than just a simple int. So when we're ++ing those other types, some other type, ++, it could be making lots and lots of unnecessary copies, wasting memory.